welcome everyone. As I mentioned earlier in the day, I'm Archit. I work on ML and agent systems in fraud and risk at Stripe. We've had discussions about agentic engineering, but I'm here to talk about agentic decision making in the context of businesses doing decisions at scale across their users. This is a pretty big focus area for Stripe with the advent of all of this like new novel systems. It is more pertinent than ever to start to leverage these systems, but also to hold them to a bar that we are happy with and that allows us the confidence to actually do like true autonomous decisions. So how do you really know your LLM systems are doing the right thing? I want to start with an anecdote. We shipped a fraud review agent to production last year. It just takes like a merchant that has signed up, runs them through some checks, and says whether they seem fraudulent or are they good to go. It might reject them. It might apply some intervention, or it will say like, "Hey, this is a good merchant." Our backtesting results were actually really promising. We saw almost twice the performance than our baseline human reviewers. So previously, this used to be done by a team of humans that would like go through a checklist and check for signals of risk. It was great. We also considered champagne. We were ready to ship. We were bolstered by the confidence in our numbers. We wanted to move fast. We launched it to AB, ramped fast. We did some manual spot checks. Said, okay, spot checks look good. Um, let's move on. But a few days later, what we found was that we were seeing much lower results than our offline evals. Um, at first, we were a bit hesitant to pull the plug, so we tried to chalk it up to label arrival. Maybe it takes a little bit longer for certain labels to mature. We said maybe it's the small data sizes of the pilot, but things didn't improve, and we, in the um, end, we had to pull the plug. So what had happened there? Well, there was a subtle label leakage bug, as often there is in ML pipelines. In our offline eval, that massively inflated our performance. Um, this would have been easy to detect in a lot of ML systems because you would see, metrics behave really weirdly. But for some reasons, LLMs are like super okay to just deal with these sort of issues. They really are good at like hiding a lot of the issues that we as a profession now know how to deal with for traditional ML systems. So in this talk, I want to talk about how we are approaching building systems that let you trust your evaluations and let you trust your LLMs. So why does this matter? As a risk ML engineer, I'll try to contextualize it in the context of what I have been working on. Um, so human reviewers are great at nuanced judgment and making calls in genuinely ambiguous cases, which is quite a frequent thing to happen in risk. And this is very high value work. However, a large chunk of this is just going to be repetitive triage. Check these 5 signals, tick off some boxes, and make a decision. With the current manual system, we are often bounded by the capacity. We have only 100 reviewers allocated. Their SLAs typically tend to be larger because you have to take into account queues and shifts and, a bunch of other things. It's also moderately expensive per case. And finally, anytime you want to move to a new review type or a new use case, a new decisioning, you're going to have to contend with a deal lead time of anywhere between 1 month to 6 months, depending on the complexity. So um, this can all be done, at least to a certain extent, by agents, especially for like the easier cases, which make the large portion of these decisions. They can achieve almost sub 30-minute SLAs. They can do each of these case reviews much cheaper. The pitch isn't to replace human reviewers, but it is to let the agents handle the brunt of the work, do the routine assessments so that the human experts can actually do the cases that require more nuance, more expertise. Um, but at and this is the whole point of this talk, right? None of this would work if you cannot prove that your agent is doing a good job. You have to be pretty solid about how you are evaluating your agents, how you are actually setting up your problem. The speed and the scale that you are afforded would not mean anything if your decisions are, wrong or suboptimal and you don't know about it. So, a quick tour down the memory lane. We've had like 3 decades of ML evolution. At the very beginning, the Big Bang, we had like our tabular models, the XGBoosts and the GBMs and the traditional feature stores. And a lot of ML stack still runs on this, and honestly, it works. You train on features which are mostly tabular. You scored in batches, and you evaluate with like train test splits. All really well understood systems. 2010s brought up a new wave of deep neural networks, which were a little bit more inscrutable, but they performed really well. We started contending with things like serving embeddings and doing learned representations, and also moving from like batch to sort of like this real-time decision making with all of the improvements in our infrastructure and in our models. The evaluation patterns didn't really change, but they got even more complex. We were still doing, classification, regression metrics on a holdout set. But again, more powerful paradigms required more powerful both infra and eval frameworks. Most recently, LLMs and even more recently, agents are taking the stage. We have things like reasoning, tool use, multi-step decisions now. The evaluation playbook that we used to rely on is starting to show some of its seams. It's starting to fall short a bit. Um, Even though each era has inherited lessons from the ones before it, there are things that are like subtly different, some subtly more nuanced. Um, so I think the biggest shift here is I think a lot of the other things around inference and running these models is mostly the same, but we are seeing that the evaluation story is where we need to be a little bit um, more careful about. I think the modality of text has both helped and made things um, harder at the same time. So, um, I think even with that, a lot has stayed the same. When I started building a lot of these agent eval infrastructure, I'd assume that I would have to be building a lot of these things from scratch, from new. But that has not been the case. Uh, when we uh, when we found that like a lot of this is following the exact same playbook, right? We are still doing offline backtest to the best of our capability. We still have our ground truth. We have our core metrics. We do an A/B test. We do shadow. We do slow ramp ups. We are still, for the most part, doing config driven experiments that allows us to chuck these beasts at strong data pipelines and using tight and cached workflows for really, really large experimentation. Um, and one final thing is that I think even now, though the shape has changed a little bit, orchestration still looks mostly the same. You still have these like massive DAGs. Maybe your granularity has changed a little bit, but you're still doing these like massive DAGs with like really high throughput and building them within like robust pipelines. So, what has changed then? I think here are a few shifts that I have found matter the most. Originally, even though models were not like inherently deterministic, they were still reproducible. You could still set seeds. You could still, do point in time correct feature data. If you had your same weights, same inputs, you would generally get the same outputs. But agents have like a lot of variability. They have temperature, they have tool choices. They might be sensitive to how the prompt is phrased. I think that structural non-determinism is not a bug. It's kind of like part of the system. Um, we used to have fixed feature, feature stores, right? Always 500 floats, always embeddings. Anything you want to chuck at it, figure out a way to convert it into numbers. Always almost the same shape. Um, for agents, you are contending with variable context. You are contending with various modalities. You could have like PDFs, images, video, 4,000 tokens of prompt, different for almost every use case and every entity. Um, we're also moving a little bit away in these use cases from our almost real time or on the hot path inference, right? Um, this breaks your SLO math if you're trying to replace a traditional model with these. So you are getting into this sort of like async path somehow. And I think the final one, which has been the hardest one to contend with, especially for decision making, you used to get this nice number between 0 to 1. You had zero point 0.9 is high, zero point 0.1 is low, 0 is great. In general, you can't ask your LLMs to simply spit out a number, right? They are famously bad at that. There are some like workarounds for that. I wouldn't recommend a lot of them. But they, even if you ask them to do it, they'll be severely miscalibrated. Structured outputs have definitely helped in this regard, where you could do sort of like a rubric and combine things, give some everything a 0 1 score. But it's still like a very um, evolving space. So that means that a lot of things remain same. So we inherit all of those failure modes, like things can still break. You could still have type issues. You could still have schema issues. But you can have so much more now. And I think the biggest one that we have been contending is, how do you know that your context is right? Like you could just push something that is bad in the context, or your context is too long and you have that like curve where like it's focusing on the start and the end. You could have like polluted stuff, you could have prompt injection, and an agent will, despite us not wanting it, just chuck through all of these issues. It will just try to find workarounds. Um, the other thing is that your tools might not be set up in the right way. You might have both like infrastructural and semantic issues with your tool. You might be querying the wrong data, or maybe your model is not querying the right tool when it is given a sea of tools to choose from. I think all of this also means that um, if you are measuring the wrong thing, it makes it super, super hard to actually address any of these things. So all of these kind of combine give you like this huge space of potential landmines that you could just like step into if you are trying to do any sort of like automated decision making. And I think you might have like personally experienced this in a smaller form in your own agentic engineering adventures, where it is getting like subtly drifting from what you want it to do, and looking at and latching on to like really really odd things that you don't really want it to do. Um so I think, how can we address that? What we have found for our endeavors here in risk is that designing the system for testability across different macro levels can greatly improve your operational posture. So, one of the things that I really really like about the way that we have decided to do our agents is to have them derived from a declarative spec. We define our inputs, we define our outputs, tools, models, prompts. We make them painfully explicit. This could be just a YAML file, or you could have it represented in code. Um, it doesn't really matter as long as it's declarative, so that you build another layer that takes that declaration and actually builds an agent out of it, rather than reinventing your agent loops again and again. This gives you an immense amount of power in doing things like baselines and candidates, where you can just generate a candidate by changing up some of the things in your existing spec. Also, versioning is super, super, super important. Prompt your tools, your model choices, your eval sets. Please go the extra length of trying to version them as much as possible. With the LLMs, cost is becoming a mounting concern. So figure out a way to cache things that you care about, cache the expensive computation, and I can wholeheartedly recommend Flight here for as a great uh, both orchestration layer as well as like a caching layer. Also, store all of the traces, not just the answers. You want to be able to do replays. You want to be able to roll back and actually see the entire decision process. Uh, One thing that sometimes get lost in the weeds when working with these like new systems is we often are going through the path of least friction, and that path of least friction often leads us to build a lot of our eval codes in notebooks and scripts and such. I think one thing that has really helped us is to treat our eval workflows as at the same level as prod code. We write tests for it, we review it, have like automated batch runs of it. If anything fails, we get alerted for it. Um, Building typed DAGs that can handle the dynamicism of these agents is also super important. Um, for us, Flight has been the substrate that we have been using for almost 4 years now. And it has been a great shift, great partner in the shift going from all of these traditional ML pipelines to all of these new and exciting and more dynamic agentic workflows as well. All right. So with all of that context and setup about some of the tribulation and some of the best practices, I want to dive even deeper into how we are doing our autonomous decision agents and how we are holding them to a high bar of performance and reliability. So this is a massive simplification, but this is how our declarative spec looks like for defining agents. This is actually pretty close to how we would actually define our risk agents these days. As I said, version your specs, version your data sets. You can um, describe what the agent does, what it takes into its context via your data sources. You have a declarative way of defining its processing. You allow it some tools. Give it a prompt. One thing that I'll really emphasize on, use the structured output, set an output schema and constrain your LLM generation to that. We've found that to be a major um, factor in improving the agent's performance and compliance. um, Capturing this entire agent behavior in this spec makes it also super easy to create experiment variants. You could just copy this over. Maybe you change the prompt, maybe you change some of the features, maybe some of the pre-processing. And your pipeline should just know how to deal with all of this. Your imperative code that is running these specs should actually mirror your schema for the agent as well. Another mental model that has been like super useful for us is to think of our decision making agents in three flavors. Data agents collect, transform, and structure evidence. Think of a data agent as something that goes to a website, scrapes it, and stores a summary. Maybe it parses a document and writes some text blob describing the document. Maybe you give it a history of transactions and it takes out like notable transactions, maybe some anomalies. It does not make any decision on its own, but it is converting your some data into some other data. Maybe it may be structured or unstructured outputs. Uh, the second tier comes with the assessment agents that can take the evidence from either these data agents, or you might have like your feature stores, or might have like all of your features or signals already in some place that might not be LLM generated. You might have some other data pipelines. They take into account all of those and might do something like, based on all of these signals, does this merchant look high risk, or is it okay to give this merchant a credit limit increase? They'll be doing the reasoning. And finally, another kind of semantic layer on top of that should be your decision agents. Your assessment agent should only be giving you generally the next suggested action, but there is a lot of policy and a lot of business logic that also lives alongside your agents that will determine whether that suggested action is actually actionable and what is the best course of applying that action. So the decision agents will take into that in the assessments and the account evidence into account. They will take the suggested action and then put it in the context of your policy, of your other context, and actually produce a holistic decision. So this might look something like, hey, the assessment agent marked this merchant as high risk, but they are a really large user. So that means we have to be even more detailed in our investigation. So maybe at that point, we might have policies around somebody who has processed more than X million in volume should always be reviewed by a human, for example. So, again, key takeaway from the taxonomy would be uh, try to keep these separate when possible. This allows a lot of cool things for you to be able to do, especially I think the separation between data agents and the assessment ones, because you would be running the same data agents all the time on all of your data to kind of create this point in time correct ledger of the past information. And then you can use that in your assessment or decision agents, and you could say, hey, I have data from my data agents. In the past, you could actually run point in time correct backtests on your assessment agents by just rereading those timestamp records of that data snapshots, as long as your other signals are point in time correct, which might be possible with feature stores and such. Um, the other thing is that if you are able to decompose your judgments into its constituent parts, which would be all of the data that had been structured as evidence and all of the assessments steps as well, it will make rollback easier. It will make testing only a single part of the system. Like if you want to just improve a single data agent, that becomes much easier. And it also makes upgrades much less painful as opposed to like one shot thing trying to one shot the entire thing. Um, in addition to splitting out your agents, it is also very, very valuable to approach the evaluation in a layered way as well. Um, you might have seen some version of this in other places as well. I've kind of shamelessly ripped it off from Maslow's hierarchy of needs. You can call it hierarchy of needs for our agent evals. Um, so at the base, as for any software or engineering systems, it's a local test. They should be checking schema tests. They should be doing output validation. You should be keeping snapshot tests for your prompts so that you don't accidentally change your prompts. Tool contract tests might also go there. The other one is going to be on top of that is going to be your back test. I talked a little bit about the importance of point in time correct data as well, but also keep a golden data set that you have like curated. It could be like as little as 10 examples, hopefully more than that, 100, 200 examples that you know cover a wide variety of your use cases and constantly measure against that. Moving on up, we have our uh, judged evals. You should be using both LLMs as judges, but also setting up a human QA process to give you actual coverage on both things. LLMs as judge are great. They have their blind spot. At least as of now, I don't know. Maybe Fable 5 solves that. But so far, you should be augmenting all of your evals with at least some amount of human in the loop, and taking and persisting their outputs and their analysis and using that to improving your evals and improving your models as well. And then the rest of it is the traditional, like do the shadow rollout, do the canaries, do the A/B test, do the real time continuous monitoring and such. So, what does this look like in practice for us? This is a simplification, but actually, this is pretty faithful to how we actually run our LLM eval pipelines. We have an experiment configuration generated by some expert. It could be an ML engineer, it could be a strategist, it could be a DS person that launches the experiment. At a point in time, we would generate some ground truth, usually from our systems labels, We would have baseline. Usually, right now it is human labels, but the baseline could also be like other agent systems that are currently in production. We massively parallelize inference through both container level parallelization as well as batching within a container using multiprocessing. Um, and then we run our eval suite that gives us all of the traditional metrics like precision, recall, AUC. But we also have come up with a bunch of dedicated metrics around accuracy, faithfulness, and doing like judged evals and like triggering human QA from the experiment process as well. Once again, all of this runs on our flight workflows. One great thing about flight is that it is typed in the IO of the task. So if we have launched an experiment that doesn't change anything about the ground truth, it will actually just cache through it. So that has been a huge multiplier in improving the speed as well as the cacheability of our experiment. You don't really want to think about this as long as your signatures are same. You should be caching. Whereas LLM costs, let me tell you, it can get out of hand really, really fast. So you want to be able to be both nimble about your execution times as well as cost conscious. The online flow, again, this follows from our evaluation pyramids. I won't talk too much about that. So yeah, what is then reliability in the online world looks like? Uh, this is what it looks like. You should be working towards building really, really solid um, metrics around observability. You should be setting up pretty strong alerting on things that can go wrong. And from experience, try to figure out more things that you can put into your um, alerting setup. Again, I think the failure modes, as usual, can be like very different. What you're looking here is an actual real production dashboard. I've uh, redacted some of the information here, but the takeaway is that you basically need the same operational rigor as you would for any other production critical service. If I did not tell you this is an agent dashboard, this looks like any other service dashboard, except the latency is like at 4 minutes, which is usual for agents. I think the two things that really, really matter for agents is one, like graceful degradation paths. So if it was not able to make an assessment, you do need to be able to hand it off to some backup system. You should not be having hard errors because these are like decision making systems that people rely on. The other one is also like concurrency control. You do not want to send off, 10,000 LLM inference call because somebody DDoS your service. Uh, so observability is the first steps towards that, like figuring out like when it is happening, and then you can have your own ways of limiting that. One thing that I do want to say is that the observability story is still pretty, pretty much in its infancy. It's still maturing, but I think we should at least start from the bar for same as any other production code that you might get paged for if you are using these as decisioning systems. All right. So what were the lessons that we've learned so far? I think the tech Twitter was abuzz with this because Boris Cherny said this recently that I write my evals first. But we actually learned this um, much before than that. Is that build your eval first before even writing the first line of your agent code. That will actually set you up for success. Second, robust workflow orchestration is not optional for production. You should not be running things off of notebooks. You want things that are reproducible, that are cached, that are observable. You also want your experimentation to scale so that you can actually ask more and more questions about how to improve things. The third thing is that existing patterns transfer directly. As I said, it's not too different from ML engineering, and I think it's not too different from any sort of tech general software engineering. So holding to the same bar. And finally, I think since agents are so crafty, they need more rigor rather than less. They make things easier to do now, but that does not mean that the things that we want to do with them are easy. So let's try to hold them at the same like level of rigor and observability as we do for rest of our system as are not lower. Quick closing thoughts. Our existing the anecdote that I said about the original failure that we had with our agent, we fixed that now. Last month we were successfully live with the new agent. It is in fully in production now. We had the A/B test and it passed with flying colors now. The other thing is strong and comprehensive experimentation suite, uh, strong evals will give you the confidence to ship more, to take on like more and more novel use cases. Start small, try one thing out, then go on to new agents, new use cases, but stick to the same discipline process. Thank you for your time.